Hey folks, we're back with lecture 2.5, which is just a really quick mini example of how to find a center of mass of a very simple system. So the problem right now has two small point masses drawn here as small spheres are connected by a 0.75 meter massless rod. Where's the system's center of mass? So right off the bat we need to define a coordinate system. And I think it would make sense to put, our 0 meters probably on our 2 kilogram mass here, just because that means that we're at positive 0.75 meters down here on the 5 kilogram mass. So the center of our system is right here. Right? The center of our system is 0.375 meters. And that is probably not where our center of mass is, right? Our mass is distributed unequally along this system. I have a heavier mass on the right side than I do on the left, so I probably don't have my center of mass straight in the middle. It's probably biased slightly to the right. Now, we've already said this, but the mass of the rod is 0. It's not adding any appreciable mass, so we don't have to worry about that. So if I'm thinking about my center of mass, let's say RCM, I could have also said XCM since we're only in the X direction here, but that would be equal to my first mass, M1, so 2 kilograms, times R1, which we've set at 0 meters. Right? That's the position of our first mass. The second mass is 5 kilograms at a position of 0.75 meters. And then we're going to divide this all by the sum of 2 kilograms plus 5 kilograms, 7 kilograms. When you plug this into your calculator, obviously the first term here goes to 0. So it's just 5 times 0.75 meters divided by 7 kilograms. I get 0.54 meters, and that confirms what we thought, that I would have some sort of center of mass probably around here-ish, right? It would be biased towards the right because that's where the heavier distribution of mass is. And that's exactly what we measured, or what we calculated. So the center of an object here, center of mass, is the quote-unquote center of the object biased by some mass distribution. The distribution of mass really affects this. Again, if you haven't looked at the video that I put up in the last, in lecture 2 description box, take a look at that. It really does a great job at illustrating and demonstrating through a demo here of how the distribution of mass biases this. So that's it. I'll see you for lecture 3.